Well, it's actually to the panel. I'm Lewis. I'm a PhD student and also running BioScout, which is fungal disease detection in real time. My question is, we're getting so specific in the resolution of disease surveillance. So Rapid Eye was talking about to 2 hectares. But another big problem is data. How are we going to use the data that we generate to produce really important regional, national data sets of disease? How are we going to balance the need to protect farmer data versus making really useful data sets? That's the whole panel.
That's a very interesting question and has so many dimensions.
I'm happy to go to have
Big
a go.
question, yeah.
So I think with any sampling problem, there's stacks of unknowns and uncertainty. And so your sampling has to be stratified. So our sampling at the scale of a farm, and depending on the outcome that you're interested in. So if a farmer has a very low tolerance and straight export, then the scale at which we need to sample, so that's all this is a sampling device, it's harvesting information, has to be at a finer scale than what the federal government needs to know whether a region is pest-free. And so there needs to be different sampling grain size, stratified for the different objectives.
Cool, yeah. I agree with that. That's, yeah. Just the only point on that is, like how do researchers and companies use that data, but also, yeah, so how are we going to stratify it? What's a concrete, do we have a concrete example of that? Sorry for getting too specific. That's all right.
So again, I think it depends on, so if a farmer subscribes, so I'll use an example, if they subscribe to RapidAIM, they own their data, but they lease it back to us to be able to do analytics for regional risk. If the federal government is paying for their subscription, that becomes their data that they lease it back to us for our regional risk assessment, so for the analytics. So as a company, that's how we're treating our situation, because we're still then on-selling the value of that as part of the different subscription models. It's who owns the data is very tricky, but we ultimately feel like who's ever paying, still, so a farmer then, for example, if they have an agronomist, then they choose to let their agronomist see that data, but the agronomist has to have a portal subscription with us to be able to access it through that app. Now that's a very specific example. It's a very complex space about who owns data, but I think that the parties involved in where it's harvested from and who's managing it, I think you can come up with some type of agreement where you're both getting benefit from it.
Cool. That's a really great answer. Thank you.
Thank you. Question up there. David.
Thanks, Joe. David Dowell from Department of Agriculture, Water Resources for Nancy. Thank you, Nancy. I was just thinking the behavioural fingerprint profile that you use, A, must be quite valuable IP, so I'm interested in how you deal with that aspect of it. And B, is it adaptable however you do that? Because if so, the possibilities of RapidAIM seem to be nearly endless.
Thanks for your positive vote of confidence. So that is our IP. So our IP is really around 2 things. One is our sensor. So I simplified it by saying the sensor that you have on your phone is similar. It is in a form of capacitance, but it's a very unique design. But then also the beauty of it is the algorithms, and that's, of course, where our IP. You can't really patent algorithms, but it's the combination. So we do have a patent on our technology. We feel like there's about 5 sensor forms and 3 physical embodiments, the way they're shaped, that can cover a whole range of insects, because in any type of monitoring for pests today that are big pests, there's often some type of lure or attractant that's also used. So major pests have meant people have invested in developing those lures. So we still have initial filter about what enters the trap based on the lure. Now, of course, you get bycatch and other things. But insects have a whole range of behaviors that we can use with the sensors and the algorithms to try to discriminate. One of the big things we're doing right now, of course, is testing false positives, false negatives. And so that's a very key, important part. And we've certainly, with our algorithm, we err on the side of trying to never get a false negative. We're at about 0.001%. The times when we do get it is if 2 flies come in at exactly the same time, then it's very difficult. That one is, but then that's a count as opposed to a detection. At the same time, we're trying to really focus on delivering this solution. We have prototype sensors sitting in the background for a moth and a beetle. I think people believe us we can develop our sensors because we've done it, but what we have to show is that we can take this to market. So fruit fly is our focus at the moment.
And based on the current cost of our eradication attempt, if you could put red imported fire ant into the mix, that would be really useful for me. However, do we have any more questions of our panel? No, we're all very quiet. Oh yes, thank you, Robin, up the back.
Robin Cleland, Department of Agriculture and Water Resources. This is a question for Hillary. It's a beautiful program, you know, both elements of the high-tech and the low-tech. And I don't want to seem negative here, but you've been going for 15 years and your aim is eradication. How far are we away from that?
Sorry. Yeah, it's tricky. The eradication program itself began in earnest, I suppose, if you want to say that, in about 2010. Hawkweed has, we think, a seed longevity for around 7 years. We don't think we've fully delimited orange hawkweed yet, which means we can't say, you know, that we have actually begun eradication, because you can't really say you've begun an eradication until you've delimited the entire infestation. So the aim is still eradication. We did have a feasibility report done in 2017, which validated that aim. What we know up till now is we do think it's still feasible. Certainly feasible for mouse ear hawkweed, because I mean we think potentially within the next 3 years that will be eradicated. The seed longevity on mouse ear hawkweed is shorter. It's about probably 3 to 5 years, and that's part of the program. We're actually testing seed longevity as well now. So eradication's long term. That's why we don't have many successful weed eradications, because we can't wait out that seed bank. So obviously animal eradications are very different to weed eradications, because we have a seed bank that we have to deal with. With orange hawkweed and mouse ear hawkweed, that seed bank is limited in, you know, it's not a 40-year seed bank. It's probably 7 maybe. So we think we have a really good chance. The trick is about delimitation. So once we delimit it, we have no problem about controlling it. We've got great efficacy of control. And that's why the surveillance is such an important component. So that's why we're investing heavily in that aerial surveillance, because without that, we don't think we have a chance of actually delimiting it. So I don't know if that answered your question, but we still have a lot of good hope for this one. We reckon it'll be our first documented weed eradication from New South Wales, hopefully in the very near future for mouse ear hawkweed. So cross fingers.
Thanks for the question, Ron. But it's an interesting point, particularly in plant and weeds, which is just, do we have those step changes that can change the paradigm for us about how we look at these? And it does seem to me a little bit of optimism is critical to keeping everyone enthused. Unfortunately.
Yeah, absolutely, and capitalising on the technology, you know, and hearing all these wonderful talks here about, you know, this technology and how do we grab that and put it into action on the ground, in particular for us in weed eradication. We haven't had one, you know, we've had some weed eradication, but very, very few. And you know, once we break that barrier of being able to find stuff from the sky, it's going to be a lot easier. And that goes to widespread weeds too. We can manage them better once we're able to find them better.
Yeah.
You can't manage it, you can't map it, right? So anyway.
That's right. Any more questions? Otherwise, I would. Was that? No, that was just someone moving their hand. You nearly got asked to ask a question. Okay. Well, thank you very much. Could you all give a big round of applause to our panelists? Thank you.